Welcome, ladies and gentlemen. So what I'd like to do is show you how to find the missing side of your triangle using our trigonometric functions. And the main important thing when using the trigonometric functions of a triangle for the missing side, we got to make sure we have everything labeled correctly. Not only do we need to make sure we know that the functions, but we got to make sure that the triangle is labeled correctly. So each of these triangles is actually a different problem. All right. So I'll do each one separately, individually, and by itself. So therefore, we can go through it. Now, the first thing whenever I see a right triangle is I want to make sure I identify all the parts, even if we're using the parts or not. So the first thing here is I can identify that the side across from my 90-degree angle is the hypotenuse. And I'm just going to label it. Even though I'm not going to be using the hypotenuse, I'm just going to label it. The side that is between my angle and my 90 degree is always my adjacent. And the other side that is opposite of the angle is called our opposite side. So we look at the given information we have here in our triangle, and we can see that we have an angle. Obviously, that's our theta. And we have the adjacent side and the opposite side. So we need to use, well, the only trigonometric function that only deals with opposite and adjacent. Well, that is tangent and cotangent. But we're going to focus on just sine, cosine, and tangent, OK? Because that's what we're going to want to use for our calculator. Anyways, so therefore, we have the tangent of 27 degrees is equal to my opposite side, which I do not know, which is A, over my adjacent side, which is 200 centimeters. So now, to solve for A, what I need to do is I need to get 200 off of the bottom. So what I'm going to do is I'm going to multiply by 200 centimeters on the right side and on the left side. OK? So therefore, that divides out to 1. And so I'm left with tangent of 27 degrees times 200 centimeters is going to equal A. Now, when you're typing this into your calculator, it's very important to make sure that your mode is in degree format, which I am. So therefore, now all I'm simply going to do is type in tangent of 27 and use either end parentheses or hit enter. And then I'm going to multiply that by 200. And we'll round it to the nearest hundredth here. And so therefore, I have 101.91 equals A. And that's going to be in centimeters. OK? So now let's go and look at the next one. So again, in the next problem, we're going to want to go through the exact same process. First thing we want to do is always identify the hypotenuse, which again, we are not using. And then in this case, you can see here, now I have my adjacent side, again, as the side between your angle and the right angle. That's my adjacent. And now I have that's not my hypotenuse. That's my opposite side. So now in this case, you can see, ladies and gentlemen, that, again, we're going to be using tangent because we're using opposite and we're using our opposite side and our adjacent side. We're not using our hypotenuse. So again, I'm going to write in the tangent. Actually, I should do tangent of theta equals opposite over adjacent. I should have written this down for the last one, but I didn't. So again, let's just plug in what we have. We have our adjacent, we have our theta, which is 38 degrees. So I do the tangent of 38 degrees is equal to my opposite side, which is 18, over my adjacent side, which is B. So now I need to solve for B. Well, now B is in the denominator. So what I need to do is I need to get B off the denominator. Just like how I got 200 centimeters off the denominator, I'm going to multiply by B on both sides. So by doing that, yes, I get B off the bottom. But now I have B times the tangent of 38 degrees equals 18. Well, I haven't solved for B yet, right? So to do that, I see that my B is being multiplied by tangent of 38. So I am going to divide by the tangent of 38 degrees. So therefore, that divides to 1. B equals 18 divided by tangent of 38. So again, go back in my calculator, and I'm just going to do 18 divided by the tangent of 38 degrees. And I get 23.04. So I can say B equals 23.04. And that is in feet. I guess I should see. And this one would have been Oh, and the last thing I didn't kind of check is to always go back and make sure that your answer makes sense. Especially if you accidentally forget to go from degree mode and you use radian modes in your calculator, your answer more than likely will not make sense. If you have like 4,000, well, that 4,000 cannot be the side length. Well, it could be, but it's not reasonable for it to be the side length given your angle, what you have here. So you want to make sure that your answer is going to make sense. All right, let's go into the next one here. So now again, we have our next triangle where we can see, hey, guess what? Now we have our hypotenuse. The side length again between your angle and your right angle is your adjacent. And we have our opposite, which we're not using. So now we need to identify, well, which trigonometric function is going to deal with the adjacent side as well as deal with the hypotenuse, and that is cosine. So I'm going to write in cosine of theta equals adjacent over hypotenuse. OK? So in this case, you can see that theta is going to be 23 degrees. So I have cosine of 23 degrees equals my adjacent side, which is 6 meters, divided by my hypotenuse, which in this case we do not know, which is c. So just like I did on the last problem, I'm going to follow the same steps. I'm going to multiply by c on both sides. Those are going to now divide out. Then I'm going to now divide by the cosine of 23 degrees on both sides. And therefore, I can say that c equals 6 divided by the cosine of 23 degrees. Just like I did over here. Basically, you're doing the same thing. You're multiplying by c on both sides. Then you're dividing by the cosine of 23 degrees on both sides. So now I basically am just going to do 6 divided by the cosine of 23. And I get c equals 6.52, and that is meters. So c equals 6.52 meters. OK, so let's go ahead and try to squeeze in this last one here. I'm going to use a different color just so I don't get everything confused. So on the last one, well, let's use black again for this. You can see here now we're given our hypotenuse. You can see that there's no side between our right angle and our theta, which would be our adjacent. And we are missing our hypotenuse, which is going to be our variable. So we need to think about, well, the heck? I mean our opposite side. I don't know where that came from. So basically what we're looking into now is what trigonometric function deals with the opposite side and the hypotenuse, and that's going to be sine. So sine of theta equals my opposite over my hypotenuse. You can see your 3 trigonometric functions, which I didn't do for the first one, but it's just very helpful to make sure you know these, OK? And especially when we're trying to find the missing side of the triangle. Whatever one, if you're dealing with a triangle that deals with opposite over adjacent, you're going to use tangent. If you're dealing with one with adjacent over opposite, you use cosine. If you're dealing with a triangle with opposite and hypotenuse, you use sine. So in this case, we do not know what the opposite is, but we do know what the hypotenuse is, which is 60. And we do know what theta is, which is 15. So I do sine of 15 degrees equals d over 60. Now, again, to solve for I told myself I was not going to use it in the same color. Let's use green. So I have sine of 15 degrees equals opposite, which is d over 60. So now, to solve for d, I need to get 60 off the bottom. So what I'll do is I'll multiply by 60 on both sides. Therefore, I'm left with 60 times the sine of 15 degrees equals d. OK? So now all I simply need to do is I need to go back to my calculator again, and I need to do the sine of 15 degrees times 60. Right, I know. 60 times the sine of 15 degrees. And I get 15.53. So 15.53 equals d. And that is just in units. So I don't need to have a measurement for it there. So there you go, ladies and gentlemen. That is how you find the missing side of a triangle using our trig functions. Thanks.